Alright, we're on to lesson 2.04, Surface Area and Volume of Prisms, Part 2. And like I said yesterday, y'all are doing great on your course and section number with your communication. Just keep it up so that way I can help you faster. Our objectives in this lesson is find the volume of any prism and develop and use Cavaliere's principle. And I do not know if I'm pronouncing that name right. Okay, so I think y'all are doing pretty good on finding the volume of a prism, but this principle is going to be totally new, but it helps make things easier as well. One of the terms that we're going to be talking about in the principle that we're going to learn is cross-section, a plane figure that results from the intersection of a plane and a solid, and you're going to get to see a picture of what that looks like. Now, Cavaliere's principle says if two solids have equal heights and the cross-sections formed by every plane parallel to the bases of both solids have equal areas, then the two solids have equal volume. Now that's a whole lot of words, because it's a whole lot of words for me. So we're going to get to see it in practice so we understand what the words mean. First, let's look at a picture. Here's you a triangular prism and here's you a rectangular prism. Okay? This red section right here, in both of them, is what we call a plane or a cross-section. Now, what this cross-section is doing, you've got this solid triangular prism. This cross-section is intersecting with that prism. Okay? It's actually intersecting. Now, what's neat about this is that this plane or this cross-section is parallel to the top base and the bottom base. Same thing with the rectangular prism. It's parallel to the top and bottom bases. Another thing that makes it kind of special is this plane right here, this cross-section, is also congruent to the top base and congruent to the bottom base. This cross-section, congruent to the top base and congruent to the bottom base. All of that helps us solve the problems that we're going to work on. Now then, a plane can intersect a prism parallel to, perpendicular to, or at an angle to the base of the prism, but all we're going to be focused on is those that are parallel to. Okay? When we're talking about cross sections, they're only going to be parallel in this lesson. Alright, so let's look at these two prisms. We have a rectangular prism right here, and we have this triangular prism, but it's not right, it's oblique. Okay, so what I want to point out here is it doesn't matter if it's two right prisms, two oblique prisms, or one right and one oblique. It doesn't matter. Okay? What we're going to look for first, remember in our definition it says they have to have equal heights. So that's what we're going to look for first. Here, this rectangular prism has a height of 7 centimeters, and this triangular prism also has a height of 7 centimeters. Okay? They have to have equal heights in order for this principle to work. Next, we're going to look at the area. I kind of made the picture bigger. We're looking at the making sure the cross sections have equal areas. Okay? So you've got this cross section right here, and when I calculate its area, it comes out to be 6 centimeters squared. Here's this triangular cross section, and when I calculate its area, it also equals 6 centimeters squared. Okay, so that principle that I read to you earlier with all that verbiage, it said they have to have equal heights, their cross sections have to have equal areas. Let's see what's next. Since they have equal heights and equal areas, the prisms also have the same volume of 42 centimeters cubed. Now, if it doesn't ask you to calculate the volume, you don't have to. Okay? What you need to know is that they have equal heights and they have their cross sections have equal areas. They will have equal volumes. What this picture does is prove to us that it's true, because they went ahead and calculated the volume of the rectangular prism and they calculated the volume of the triangular prism, and they both came out to be 42 centimeters cubed. Now let's go on to finding the volume. It says the formula for the volume of prisms, V equals capital BH multiplied by H, can be used to find the volume of any prism regardless of whether it's right or oblique. So here's the right prism I was just using in the other example. Okay, right prism, and you go look right here where they had calculated the volume. Here's an oblique prism. They calculated the volume of it using the same formula. That's all I'm wanting to point out here, is that they used the same formula for both of the prisms. Now highlighted in yellow down here it says, when finding the volume of an oblique prism, be sure to use the height, not the slant height. So notice over here this dashed line, that's the actual height. If you took this measure right here, that would be the slant height, and you would not get the correct answer. Okay, so let's look at this triangular oblique prism, or let me say that correctly, oblique triangular prism. And we look and we see that it's a right, the triangle base are both right angles, and the legs each measure 4 centimeters. And although it doesn't look like it, this height right here is also 4 centimeters. Okay, so what we're going to have to start out when we're looking for the volume, remember that capital B? Capital B means area of the base. So we're going to have to find that first. So here's the capital B, and remember for finding the area of a triangle, it's going to be half base times height. So look at my base and my height are both 4, so I'm going to plug those in. So I got a half times 4 times 4. And I'm going to get 8 centimeters squared. So my capital B in V equals BH is going to be 8. So let's find the volume. There's the formula. Capital V equals capital B times little h. So I'm going to plug this 8 in for the capital B, and I know what my height is. It's going to be 4. So I'm going to plug that in for the little h. So I'm going to have 8 times 4, and I'm going to get 32 centimeters cubed. Remember, your volume's always cubed. Okay, now let's do a problem with the Cavaliere's principle. And we're going to determine which prisms have equal volume. Okay, there's 4 prisms here. Only 2 of them have equal volume, and we got to figure out which one. So I outlined in red here so we'd be able to see the problem being worked out. It says compare the cross-sectional areas, and what that means is I'm going to find the area of this cross-section. I'm going to find the area of prism B's cross-section, the area of prism C's cross-section, and the area of prism D's cross-section. So prism A's cross-section area is 84. Prism B's cross-section is also 84. And notice how they're using the formulas that are respective to the shapes. You've got length times width for this parallelogram. You've got half the length times width of this triangle. And now we're probably going to use length and width for prism C, and then half the length and width for prism D. Oh look, prism C's is also 84. And prism D is going to be 54. Now prisms A, B, and C have the same cross-sectional areas, so that means prism D is out of the picture now. Okay, we know we're not going to use it for anything. And when you're working problems like this, especially, well, y'all aren't doing standardized testing anymore, but in case you have to, you always get rid of that choice. We know he's done. We're not going to worry about him anymore. Next, we're going to compare the heights. And I went ahead and used these little red circles, and I circled the height of each one. Well, remember we said we don't care about prism D anymore. He's gone. Well, if I'm going to compare the heights, here's 8, here's 8. Let me get rid of my little palette. And I come down here, and the height of prism C is 10. Remember, they have to have equal heights, and the cross-section area has to be equal. So that means prism C is out of the picture. So let's check our answer. It says comparing the heights, and we did that when I circled them in red and we talked about it. So it says, oh, let me get my pointer. Okay, prisms A, B, and D have the same heights. Prism A and B have the same cross-sectional areas and equal heights. Therefore, prism A and prism B are going to have congruent volumes or equal volumes. Okay? Now, remember when we read the principle, it sounded lot of words and it sounded like it was going to be hard, but it's not hard at all. Okay? You're just going to have to figure out which ones have equal heights, which ones cross sections have equal areas. Then you will know who has equal volumes. Okay, I got a couple of volume examples that I wanted to go through with you. They're usually polygons that I go through because polygons are a little tougher because we're not as familiar with their formula. Okay, so I like to go over those with you. Here's the formula for volume. Now, if I'm going to find the area of a pentagon, remember the formula for any area, the area of any polygon is a half multiplied by the apothem multiplied by the perimeter. So they come down here and they start out by calculating the perimeter. This edge right here is 4, and they don't really tell you this, and it's kind of the curriculum fault, but all these sides are congruent. They're all the same size. They're all 4 yards. So since it's a pentagon, it has 5 sides. 5 times 4 is going to give us a perimeter of 20. And if you look right here, I've told you this is the apothem, and it measures 2.75 yards. So we're going to plug that 20 in for the capital P, the 2.75 in for the A, and I believe if you look right here, this is an oblique, but the height is going to be 7, because you always go by the height of the prism, not the slant height. So, we're going to find the area of the base. I guess we could have clicked on that first instead of telling you what we were going to plug in. So here we go. They did just what I said. Little a is the 2.75, capital P is the 20. They put that in their handy dandy calculator and got 27.5 for the area. So remember, we're looking for volume. We just found capital B, and we know what the height of the prism is at 7. So the area is 27.5 yards squared. Find the volume. So in for capital B, I got 27.5. For the height, I got 7. Handy dandy calculator tells it's 192.5. So the volume is 192.5 yards cubed. Let's look at another example. Angelica is shopping for an aquarium. She has narrowed her choices to 2 aquariums. She can choose one that has regular hexagonal bases or one that has rectangular bases. If she wants to buy an aquarium with the greater volume, which aquarium should she choose? So you're going to have to figure out the volume, for each one of the prisms. So here's the rectangular volume. Remember, your formula is capital V equals the area of the base times height, so you got to calculate the capital B first. They got the length times the width. 18 times 24 is 432. They plug that in, and if you look over here, the height is going to be 21. So the volume of the rectangular aquarium is 9,072 yards cubed. So now we're going to find the volume of the hexagonal aquarium. So remember that funky formula for the polygons is the area of the polygon is going to be a half multiplied by the little a multiplied by the perimeter. So that's why they're calculating the perimeter first. Okay, so they're going to have a hexagon has 6 sides. Each one of the sides is 12, and I see that right over here, 12 yards. And when I multiply those, I'm going to get 72. So here's the formula for the area of the hexagon. A half little a times capital P. Plug the 10.4 in for the apothem, the 72 in for perimeter. Calculate that, 374.4. Now I get to plug all that into my volume formula to figure out the volume. So remember, my capital B was 374.4. My height is right here. It says 24 yards. So I plug that in for the little h, and that's my answer. I get that the volume of the hexagonal aquarium is 8,985.6 yards cubed. So let's go back to our question. It says if she wants to buy the aquarium with the greater volume, which aquarium should she choose? She should purchase the rectangular aquarium because it has the greater volume. Okay, what we learned today, Cavaliere's principle states that if two solids have equal heights and the cross sections formed by every plane parallel to the bases of both solids have equal areas, then the two solids have equal volume. Remember, what you want to know in that equal heights, equal areas of the cross sections are going to have equal volume. Okay? The formula V equals capital BH can be used to find the volume of any prism where B is the area of the base and H is the height.